Hello students. In the earlier classes of differentiation, you have seen the function in the form y is equal to f of x, which was either an explicit function or an implicit function. Any form of equation in the form y equal to f of x. Any case of equation in the form y equal to f of x, you are able to find dy by dx using different methods of differentiation. Now observe this. X is equal to sine theta and y is equal to cos theta. Here you can observe that x and y are expressed as two different functions of third variable, that is here theta. In the earlier case, y was expressed as a function of x. X and y were related in one equation, whereas here x and y are expressed as functions of the third variable. Here, the third variable theta is called the parameter. Third variable theta is called the parameter. So, the relation between x and y in terms of the third variable, which is parameter, that is x equal to the function of theta and y is equal to the function of theta. So these expressions are called the parametric equations. Parametric equations. Now the question is, when the parametric equations are given in the form x equal to f of theta and y equal to g of theta, how to find dy by dx? How to find dy by dx? Observe, here x is the function of theta. So let's differentiate x with respect to theta. That is, find dx by d theta. And for this example, it is cos theta. Similarly, y is a function of theta. So differentiate y with respect to theta. That is to find dy by d theta. And here it is minus sine theta. Now, dy by d theta divided by dx by d theta. This division gives us dy by dx. D theta get cancelled, so we get dy by dx. So therefore, dy by dx is given as dy by d theta by dx by d theta. Dy by dx is dy by d theta by dx by d theta. And for the given example, it is dy by d theta is minus sine theta by dx by d theta is cos theta, which is equal to minus tan theta, which is the function of the parameter theta. So this procedure or this method of obtaining dy by dx for the given equations, that is parametric equations, is called parametric differentiation. The method of obtaining dy by dx, okay, which is given in the form dy by d theta by dx by d theta for the parametric equations is called parametric differentiation. Make a note that the parameter used the parameter used in parametric equations could be either theta or t. So any variable can be used. So if x is a function of t and y also the function of t, then we need to differentiate x with respect to t and y with respect to t. Then dy by dx is obtained in case of t, when the variable or the parameter uses t will be dy by dt by dx by dt. So this is about the parametric differentiation. We have learned now the procedure or the method of parametric differentiation. So let's take some examples. Let's work out few questions. So from exercise 5.6, the question goes like this. Find dy by dx. Find dy by dx in the following. So first question in this is x equal to 2at square and y is equal to a t to the power 4. So as I told you earlier that the third variable used could be t or theta. So here it is t. So what we need to do, as x and y are the functions of t, let's find dx by dt as well as dy by dt. That is, differentiate both x and y with respect to t. So what is dx by dt? 2a into t square, constant into variable. So we know to differentiate constant into the derivative of t square with respect to t is 2t. So dx by dt is 4at. Same way, derivative of y with respect to t, a into t to the power 4, constant into the variable. So write the constant as it is. Derivative of t to the power 4 is 4t cube. So dy by dt is 4a into t cube. Then dy by dx, that is given by dy by dt divided by dx by dt. That is, dy by dt is 4at cube by dx by dt is 4at. So on simplification we get t square. 4a get cancelled, 1t get cancelled, so remaining is t square, which is again the function of the third variable t. So this is how we find dy by dx in case of parametric equations. Another example, another question. So second question, x is equal to a cos theta, y is equal to b cos theta. Observe, here the parameter used is theta. So as x and y are the functions of theta, let's find the derivative of x and y with respect to theta. So find dx by d theta, constant into function. So constant into derivative of cos theta with respect to theta is minus sin theta. Similarly, derivative of y with respect to theta is constant into derivative of the function, that is minus sin theta. So now dy by dx, that is equal to dy by d theta. Now it is not dt. Okay, so dy by d theta by dx by d theta, that is minus b sin theta divided by minus A sine theta, which is equal to B by A, which is the independent of the variable. Okay, it is purely a constant. The third question is x equal to A into theta minus sine theta and y is equal to A into 1 plus cos theta to find dy by dx. So now we can observe that x and y are functions of theta. So find dx by d theta and dy by d theta. Differentiate both with respect to theta. Constant into the function. So constant into derivative of theta with respect to theta is 1 minus derivative of sine theta is cos theta. Same way, derivative of y with respect to theta, that is dy by d theta is constant into function. So constant into derivative of 1 is 0 plus derivative of cos theta is minus sine theta. So now dy by dx, which is defined as dy by d theta divided by dx by d theta is equal to minus a sine theta divided by a into 1 minus cos theta, which is equal to minus sine theta divided by 1 minus cos theta. Now here, for this we can simplify the function. We can write the answer in the simplest form, that is dy by dx is equal to minus sine theta can be written as 2 sine theta by 2 into cos theta by 2 using sine 2 theta formula, and 1 minus cos theta is a standard one, that is 2 sine square theta by 2. So these are the standard trigonometric formula. Multiple angle formula we have used in the numerator, that is sine 2 theta formula, and here the standard one, 1 minus cos theta is 2 sine square theta by 2. So on simplification, the 2 get cancelled, 1 sine term get cancelled, and what remains is minus cos theta by 2 by sine theta by 2 is nothing but cot function. So cot theta by 2. So this is dy by dx for the given functions. The next question, x is equal to 4t and y is equal to 4 by t. X and y are the functions of t. Here the parameter used is t. Okay. So let's differentiate x and y with respect to t. So dx by dt, 4 into derivative of t with respect to t is 1. Similarly, dy by dt, derivative of 4 by t, that is 4 into 1 by t. So 4 into derivative of 1 by t is minus 1 by t square. So it is minus 4 by t square. So now dy by dx is equal to dy by dt divided by dx by dt, that is minus 4 by t square by 4. So what happens here? 4 get cancelled and remaining is minus 1 by t square. So this is dy by dx. So you have observed that when x and y are expressed in terms of the third variable, that is parametric equations are given, dy by dx is a function of that third variable, the parameter used, or it is purely a constant. Take up the next sum. The next sum is x is equal to sine t and y is equal to cos 2t. Here x and y are the functions of t. Parameter used is t. So let's find dx by dt and dy by dt. So dx by dt is cos t, derivative of sine t with respect to t, and dy by dt is cos 2t. It is a composite function, so we need to use the chain rule. Derivative of cos function is minus sine 2t into the derivative of 2t with respect to t is 2. So therefore, we get dy by dx, that is given by dy by dt by dx by dt, that is equal to minus 2 sine 2t divided by cos t. This can be simplified further using the multiple angle formula sine 2 theta. So sine 2t is 2 sine t into cos t. 2 sine t into cos t divided by cos t. So what happens here? Cos t get cancelled. So we get minus 4 sine t. Minus 4 sine t. So that is dy by dx for the given equations. For the given equations. Next question is x is equal to a cos theta and y is equal to a sin theta. So here observe x and y are the functions of theta. So differentiate x and y with respect to theta. So dx by d theta is a into derivative of cos theta is minus sin theta. Similarly, derivative of y with respect to theta is a into derivative of sin theta is cos theta. Therefore, dy by dx, which is given by dy by d theta divided by dx by d theta is equal to a into cos theta divided by minus a into sin theta, which is equal to minus cos theta by sin theta is cot theta. Next sum will take up. So next sum is x is equal to a into cos theta plus theta sin theta and y is equal to a into sin theta minus theta cos theta. x is equal to a into cos theta plus theta sin theta, and y is equal to a into sin theta minus theta cos theta. So here both x and y are functions of theta. So differentiate them with respect to theta. So dx by d theta is constant into function. So write the constant as it is. Find the derivative of the function. Cos theta, whose derivative is minus sin theta, plus. Now the second part, just observe, it is theta into sin theta. So product of two terms or functions. So we need to use the product rule. You are all familiar with the product rules. What is that? The first term into derivative of the second term. So that is here cos theta plus second term into the derivative of the first term with respect to theta, that is 1. So here we get dx by d theta as a into, you can observe here minus sin theta, and here we got sin theta into 1, that is sin theta, so get cancelled. So we get a into theta into cos theta, that is for dx by d theta. Y is also the function of theta, so find dy by d theta. So dy by d theta is constant into the derivative of the function. Derivative of sin theta is cos theta minus, again we have product of two terms, theta into cos theta. So use the product rule. So what is the product rule? First term into derivative of the second term, that is minus sin theta, plus second term into derivative of the first term, that is theta, with respect to theta, which is 1. See, observe here you need to put the bracket when you use the product rule, because you know in the product rule there are two parts we get, and there is minus sign out, and this minus sign has to be assigned to both the terms. So put the brackets. Okay. So now we will simplify this. It is a into cos theta, open the brackets, minus of minus, plus theta into sin theta minus cos theta. So what happens here? Cos theta minus cos theta, it cancels. So we get dy by d theta as a into theta into sin theta. So finally, dy by dx is equal to, it's given by dy by d theta by dx by d theta, that is equal to dy by d theta is a theta sin theta divided by dx by d theta is a theta cos theta, that is equal to tan theta. So this is dy by dx. We'll move to the next question. It is, if x is equal to square root of a to the power sine inverse t and y is equal to square root of a to the power cos inverse t, then show that dy by dx is equal to minus y by x. Observe, x and y are the functions of t. But if you observe carefully, both the functions are the composite functions. In here you have square root of a to the power sine inverse of t. So you need to use a chain. That will be lengthier. So what we can do here is, we need to first simplify the function. What we do here is we find the product of x and y. So x into y is square root of a to the power sine inverse t into square root of a to the power cos inverse t, which is, we know that root a into root b is root of a into b. So root of a to the power sine inverse t into a to the power cos inverse t. That is root of multiplication of two indices the same way is done by adding the powers. So root of a to the power sine inverse t plus cos inverse t. So x into y is equal to square root of a to the power. What is the sine inverse t plus cos inverse t? This is one of the standard result in inverse trigonometric function, which we are going to study in detail in inverse trigonometric function chapter. So remember, the result goes like this: sine inverse t plus cos inverse t is equal to pi by 2. Now square root of a to the power pi by 2 is a constant. A is a constant, pi by 2 is a constant, constant to the power constant is a constant, root of a constant is again a constant. So now let's differentiate this. Left hand side is done by using the product rule. So first term into derivative of the second term with respect to x plus second term into derivative of the first term with respect to x is equal to, as the right hand side is purely a constant, its derivative is 0. So from this, x into dy by dx is equal to minus y. Therefore, dy by dx is equal to minus y by x, the given answer. Okay, so this is one different type of problem where we use the result in inverse trigonometric function. So we first find xy and then differentiate, easily you will get the answer. So with this, the parametric differentiation is done. So I hope it is clear. Thank you.